So on page 4 in chapter 1, the next thing we want to start talking about are functions and their graphs. So how do you visually see a function? How do you describe it? Couple of things for describing. First of all, we talked about functions as a special type of relation, and we talked about the vertical line test. We said that that vertical line test is when you're looking at a function and you're saying, okay, do I ever cross this graph more than once with a vertical line? So this one would pass our vertical line test. Yes, it's a function, versus maybe a sideways one. You say, I'm hitting it twice, not a function. That's what we use that for. The next thing is to say whether or not the graph is increasing, decreasing, or constant. Whenever you read a graph, you want to think about reading it the way you read a book. You read it left to right, so from the left towards the right, and what you're asking is, as I come this way, what's happening to my graph? It's going up, it's increasing to the top of a hill, and then it starts to come down a hill, and then it goes back up a hill again as we come across the graph. That's what we mean by increasing or decreasing. So where are you increasing or decreasing? We use interval notation to help us describe these places on a graph. So increasing, this arrow tells us that we're going to continue in this direction on to infinity. So from negative infinity on the x-axis all the way over here, again, interval notation are always x-axis variables. We've been increasing, increasing, increasing. Where do we stop? Well, right here is where we stop increasing. So that section is at -2, 1, but again, we're only dealing with x variables, so we say up to -2. Then we're no longer increasing, we're then decreasing. So we're decreasing from -2 until right about here, which on the x-axis is about 1/4, 1/3, somewhere in there. And then from this point, we start to increase again. So we can go back up here and say we are increasing from positive 1/4. The graph's going to continue all the way out to infinity, to positive infinity. So these sets of numbers here are only using x values to describe what's happening with the range of the function. If you look at this x description from negative infinity to -2, we're actually describing that the range is going upwards if you look at it sideways. And again, from 1/4 to infinity, we're looking at the range is increasing as we go over that particular section. From -2 to positive 1/4, this little section right in here, if you look at the range, the function is decreasing in range. So this is like an increasing range and a decreasing range, but again, you're only using x values for interval notation. The last one here, staying constant, this graph does not show us a staying constant because you have to be able to see a straight section of a graph in order to say it's a constant. So this part of a graph right here could be a constant section, but nothing here. These turning points are something else. Those turning points are what we call relative maxes or relative mins. In order to find relative maxes and relative mins, you're going to use your graphing calculator, especially when you get to the higher degrees. And then there is a document that you can use if you don't remember how to do this, but we're going to use left and right bounds to help us with this. So example 9, finding relative maxes and relative mins. First of all, you take your function and you go to your y equals, and we're going to plug this in, x to the third minus 2x squared. There's our swoosh function. To find the relative max into relative min, second calc, minimum, and then we need to go to where we think this little one here is the minimum. It's going to ask for the left bound, so come over here near it, hit enter. Right bound, hit enter, guess, yes, hit enter again. It approximates our minimum to be 1.33 and then y negative 1.18. So relative min is at 1.333 comma negative 1.185, the relative min. And then our relative max up here, again, go to second calc, number 4, left bound, right bound, guess. It tells us 1.1541 e to the negative 6, negative 2.66 e to the negative 1/12. Remember when you see those e's, that's like a 10 to the something power? And what that's telling us is that it's actually really, really, really close to 0. Sometimes your calculator will tell you those numbers. For us, if I did a trace and I said, what's at 0, 0 there, that's about where that maximum is. So we're just going to call it 0, 0 for easiness sake, because something to the negative 6th power means 0.000000 number, and that's close enough to 0 for us.